Welcome back, students. This is the session number 8 from the chapter of moving charges and magnetism, and this is the Q&A session in which I have taken one question from the NCERT book. This question is available in the NCERT book, and you can access it. So the question is: an electron moves with a speed of 3 into 10 to the power 7 meter per second in a magnetic field which is perpendicular to the direction of motion of this electron. So we have to find the frequency and the energy of this electron in electron volt. Energy has to be found in electron volt, and we will be finding this frequency in hertz. The mass of the electron is given as 9 into 10 to the power minus 31 kg, and the charge on the electron is equal to 1.6, which is, I have not, let us say E is equal to, that is, the charge on the electron is equal to 1.6 into 10 to the power minus 19 coulomb. So these are the two things which has been given in this question. And so now let's start doing this question. An electron is moving with a speed of 3 into 10 to the power 7 meter per second in a magnetic field which is perpendicular to it. So let us try to solve this question with the help of this Cartesian frame of reference, which consists of a x, y and z axis. So I have just, this is z axis. Now let us consider that let's say the magnetic field is along this x direction. So since the electron is moving in a magnetic field which is perpendicular to it, so let us consider that this electron is moving along the y direction, because x and y are perpendicular to each other. So let us say the velocity of this electron is along the y direction, and this is equal to 3 into 10 to the power 7 meters per second. And this is the velocity of this electron in this direction. Now, we know that the magnetic force is always perpendicular to the direction of the magnetic field and to the direction of motion. So now in this case, we have taken the direction of the magnetic field along the x-axis, and I have taken the direction of motion of the electron along the y-axis. So since the magnetic force is perpendicular to this velocity of this electron, is perpendicular to the direction of velocity of this electron, and it is also perpendicular to the magnetic field, so the magnetic force will be acting along the z-axis, and this magnetic force will drive this electron in a circular path. That is FB, that is the magnetic force will provide the necessary centripetal force for the electron to move in a circular path. So it implies that now we know that the magnetic force is equal to Q into V into B. Q, VB, where Q is the magnitude of the charge, V is the velocity of this electron, and B is the magnitude of this magnetic field. So this will be equal to, now this magnetic force will provide the necessary centripetal force, and the centripetal force is given by mv square by r, where r is the radius of that circular path, v is the velocity of this electron, and m is the mass of the electron. So from this equation, if I will cancel out this v on both sides, so I will be getting that r will be equal to mv divided by qb. That is, the radius of this circular path is equal to m into v divided by q into v. So first of all, we have to find the radius of the circular path of this electron due to the this magnetic field. So R will be equal to, now the mass of the electron is given 9 into 10 to the power minus 31 kg. V is equal to 3 into 10 to the power 7 meter per second, and it divided by q. Q, the value of this, that is the value of the charge on this electron, is equal to 1.6 into 10 to the power minus 19 coulomb into B, the intensity of the magnetic field, which is equal to 6 into 10 to the power minus 4 Tesla. So this is the value of the radius of the circular path, which will be which the electron will follow due to the action, or you can say under the influence of this magnetic field. So R will be equal to, this is equal to 27 divided by 9.6 into 10 to the power, this is minus 37, this will go minus 24, and this one is 10 to the power minus 19, and 10 to the power minus 4, that is equal to 10 to the power minus 23, and when it goes into the numerator it becomes 10 to the power 23. So finally I am getting is as 27 divided by 9.6, 27 divided by 9.6, 2.81. So this is the value of this into this is into 10 to the power minus 1. So it implies that R will be equal to 2.81 divided by 10. This is equal to 0.281 meters. So R, that is the radius of the circular path, is equal to 0.281 meters. Okay, this is the first thing which we have calculated, that is the radius of the circular path. And now we also know that this V is equal to R omega. Okay, that is whenever a particle is moving in a circular path, then V is the this is the linear velocity, omega is the angular velocity, and R is the radius of that circular path. So this is equal to R into omega is equal to 2 pi upon T, where T is the time period, and 1 upon T is equal to the frequency. So I will write I will replace this 1 by T by F. So I will be getting as 2 pi R F, where F is the frequency of this electron. So it implies that F क्या हो जाएगा? F will be equal to V divided by 2 pi R. Now V की वैल्यू हमें दी हुई है 3 into 10 to the power 7 divided by 2 pi, and R की वैल्यू हमारी जो आई थी that was equal to 0.281 meter. So now F will be equal to 2 pi, I'm taking the value of pi as 3.14 into 0.281. So the denominator is equal to 1.764 into 10 to the power 7 divided by 1.76. Okay, I'm just taking it as 1.76. So this is equal to 3 divided by 1.76 is equal to 1.70. So this is equal to 1.70 into 10 to the power 7 per second, or frequency will be equal to 1.7 into 10 to the power 7 hertz. So the frequency F is equal to 1.7 into 10 to the power 7 hertz. ठीक है? So now we have calculated the value of frequency. Now we have to calculate the energy of the electron. The energy of the electron is to be calculated. So now the energy E is equal to half mv square. Half m is given as 9 into 10 to the power minus 31 kg, and V velocity, the value of the V is given here, that is 3 into 10 to the power 7. So if we square it, then it will become 9 into 10 to the power 14. So finally we are getting as 981, that is 81 divided by 2, that is equal to 40.5 into 10 to the power minus 17 joules. Okay. Now this is the energy of the electron in joules. Now we have to find the energy in terms of electron volt. Now we know that this 1 electron volt is equal to 1.6 into 10 to the power minus 19 joules. Okay. So it implies that 40.5 into 10 to the power minus 17 joules is equal to, this much of joules is equal to 1 electron volt. So 40.5 into 10 to the power minus 17 joules will be equal to 40.5 into 10 to the power minus 17 divided by 1.6 into 10 to the power minus 19. So it implies that the energy in electron volt will be equal to 40.5 divided by 1.6, 40.5 divided by 1.6 is equal to 25.3 into 10 to the power, this is minus 17, and when this 10 to the power minus 18 goes in the numerator, so it will be equal to 10 to the power 2 electron volt. Okay? So the energy of the electron in terms of electron volt will be equal to 25.3 into 10 to the power 2 electron. Energy of the electron is equal to 25.3 into 10 to the power 2 electron volt. So energy we have calculated, that is equal to 25.3 into 10 to the power 2 electron volt. We have also calculated the frequency, that is equal to 1.7 into 10 to the power 7 hertz, and we have also calculated the radius of the circular path of the electron, which is equal to 0.281 meter. So this is all I have for this session, and in the next session we will be continuing with this Q&A sessions, and so till then, have a nice day. Bye.